In this section, we're going to look at motion under gravity as an example of uniformly accelerated motion. So let's look at motion under gravity. Now, gravitational motion is a uniformly accelerated motion. That is, the velocity of a falling object increases at a constant rate. So motion under gravity is uniformly accelerated motion. That implies the acceleration due to gravity is a constant. That is, the velocity of a falling object increases at a constant rate. Now, the numerical value of gravitational acceleration is, let's say value is 9.8 meters per second square. Okay, the velocity of a falling object increases at the rate of 9.8 meters per second. Okay, now let's look at the direction of the acceleration. If you throw an object upwards like this, you know the velocity decreases. Okay, so that tells you the sign for acceleration or gravitational acceleration should be negative, but you might say its velocity increases as it goes down. Okay, but remember, a downward velocity is a negative velocity, so it's an increase of a negative, which is still a decrease. Okay, so it goes up, we have a decrease of a positive value, which is a decrease, and when it falls, we have an increase of a negative value, which is still a decrease. So in any case, gravitational acceleration is negative. Okay, it's customarily denoted by the letter G. So we have gravitational acceleration equals negative 9.8 meters per second square. Okay, so gravitational acceleration is a constant and its value is negative 9.8 meters per second squared. Okay, now let's look equations of gravitational motion. Gravitational motion. Okay, we have already developed the equations of a uniformly accelerated motion. All we're going to do is replace the acceleration by g, which is negative 9.8 meters per second square. So for this motion, we know a equals g, which is negative 9.8 meters per second square, and instead of delta x, we're going to use delta y because the vertical motion. Okay, so instead of delta x, we're going to use delta y because it's a vertical motion. Okay, so the equations we wrote for uniformly accelerated motion were the following: Vf equals Vi plus acceleration times t. Okay, that will go to Vf equals Vi. We're going to replace acceleration by g because now we know its value. Okay, and the second equation, delta x equals Vit plus half at squared. Okay, we're going to replace delta x by delta y because the vertical motion. So you've got delta y equals Vit plus 1/2, and we're going to replace the acceleration by g. We've got gt squared, and then we have the following equation: Vf squared equals Vi squared plus 2a times delta x. Okay, so we have Vf squared equals Vi squared plus 2. We're going to replace a by g. We have 2g delta x, and the last equation was delta x equals Vi plus Vf over 2 times t, and that equation becomes, we're going to replace delta x by delta y because of vertical motion. We've got Vi plus Pf over 2 times t. So these are the 4 equations you can use for motion under gravity. Okay, so in this case, you see we have only 4 variables because we know the acceleration. Okay, so we have only 4 variables. They are Vi, Bf, t, and delta x. Okay, and remember, only those two equations are independent. We can solve only for two variables. So for this kind of motion, if you know two of the variables, you can always solve for the other two. Okay, and also you have to remember to use the sign convention for each variable. For velocity, up is positive, down is negative. If it's going upwards, the velocity is positive. If it's going downwards, the velocity is negative. For delta x, delta y, sorry. If it's going up, the change in y is positive, that's y is increasing. If it's going down, the change in y is negative because the value of y is decreasing. Okay, so the sign conventions are velocity is positive if it's going upwards, negative is going downwards. The displacement delta y is positive is going up, negative is going down. Okay, so the conclusion is, if you know any two of this, you can solve for the other two. You can solve for the other two. Now let's look at some examples. Okay, let's say an object was dropped from a height of, let's say, 20 meters. Okay, so let's solve for the following variables. Let's solve, for example, for the time taken. Okay, time taken, question mark. Okay, so what we have is, we have this object dropped. Let's say it's the ground over here. Is dropped, and this height is 20 meters. Okay, so first let's write what we know. Okay, dropped means it's starting from rest, so the initial speed is 0. And the other thing we know is displacement. Okay, now it's very important to distinguish between positive and negative. In this case, it's going downwards, the value of y is decreasing, so delta y is negative. It's 20 meters, but it is negative because it's going down. Okay, so we have delta y equals negative 20 meters. So that's what we know. Now we have to go to these 4 equations and see which is the best equation to use. Okay, what we know is vi and delta y. We already know acceleration. Okay, so if you look at this equation over here, delta y we know, initial speed we know, so from this equation we can solve for time. So we're going to use the second equation. Second equation is delta y equals initial speed times time plus half gt squared. Okay, so the change in y is negative 20, the initial speed is 0. Okay, plus half. To make the calculation easier, I'm going to use negative 10 for gravitational acceleration, but you have to use 9.8 all the time. So you've got t squared over here. All right, so you've got negative 20 equals negative 5 t squared. Okay, so t squared equals 4. That implies the object took 2 seconds to hit the ground. Okay, the other variable we can calculate is the speed just before it hits the ground. So speed just before it hits the ground. Okay, so we're being asked for the speed over here, that's bf. Okay, we have to calculate the final speed right over here. All right, so looking for this one. Okay, so now pretty much we can use any equation that has VF in it because we know all the other four variables. Maybe we can use the first equation, VF equals VI plus GT. Okay, the initial speed is 0 because being dropped. Gravitational acceleration is approximately -10 times time. Okay, and the time is of course 2 seconds. This is 2 seconds, so that is -20 meters per second. Okay, so the final velocity is -20 meters per second. Why is negative? Because it's going down. Another example, let's say an object is thrown upwards, with a speed of 20 meters per second. A, calculate the maximum height reached. The maximum height reached. Okay. Now, let's say the ground is being thrown upwards with a speed of 20 meters per second. Okay, so what's going to happen is go up, but because of gravitational acceleration, it's going to slow down, and then eventually its speed will become 0 and then turn around and come back this way. That's going to happen, right? So this is the maximum height, delta y, we're looking at. Okay, returning over here, so this is the maximum height reached. So we want to calculate delta y. Okay, let's write what we know. The initial speed is 20 meters per second, and it's upwards, so it's positive. Okay, so we've got VI equals 20 meters per second. Now, what do we know at the maximum height? You see, the velocity as goes up will decrease. Eventually, the maximum height, the velocity becomes 0 and then comes back. Okay, so at this point, the final velocity is 0. So you have to remember the final velocity at the maximum height is always 0. So now we should be able to solve the problem. We have initial velocity and final velocity. Of course, we know acceleration, we want to solve delta y. So you look at the equations and you select the suitable equation. Okay, so the equations, we have v final, v initial, we know g, we want to solve for delta y, this is delta y. Okay. So we're going to use that equation. We have Vf squared equals Vi squared plus 2 times G times delta y. Okay, so at this point, Vf is 0. So you've got 0 equals 20 squared plus 2 G approximately -10 times delta y. Okay, so you've got -400 equals -20 times delta y. Okay, so delta y is 20 meters. So we got a positive answer for delta y because it's moving up. Okay, and then we can calculate time taken to reach the maximum height. Time taken to reach the maximum height. The maximum height. Okay, now you can pretty much use any equation that have time in it because we know all the other variables. Maybe this is the easiest equation to use, Vi plus G times T. The final velocity is 0. The initial velocity is T. This is approximately -10 times T. Okay, so we've got -20 equals -10T This implies t is 2 seconds. So it will reach 2 seconds to reach the maximum height. Now see, let's say, how long does it take to return to the ground? Return to the ground. Okay, so this motion is symmetric. That is, the time taken to go up and the time taken to come down are equal. Okay, so if it took 2 seconds to go up, it will take 2 seconds to come down. So the time taken to return to the ground is 4 seconds. Or if you want, you can say, let's say start from here. It's going back over here. So the initial point and the final point are the same. Okay, which means delta y is 0. All right, and we know the initial speed is 20 meters per second. Okay, so from this information we can solve for the time. We have the following equation: delta y equals vit plus half gt squared. Right, now for this motion, since the initial and the final are the same location, delta y is 0, so you can put 0 over here, and this is 20 times t, and this is approximately negative 10, so it's going to be minus 5 t squared. Okay, so we can divide the whole equation by t. We've got 0 equals 20 minus 5t. Okay, so 5t equals 20, and that implies 4 seconds. But as I've said, you don't have to go through this because the motion is symmetric. If the time to go up is 2 seconds, the time to come down is also 2 seconds, so the total time to come back is 4 seconds. Okay, let's look at another example. Now, let's say a ball is thrown upwards from maybe a 10-meter building, let's say with a speed of maybe 5 meters per second. Okay, so what we have is we have an object being thrown from the top of a building with a speed of 5 meters per second. Okay, and this is 10 meters, the building is 10 meters high. Okay, so let's ask some questions. Let's say calculate its speed just before it hits the ground. Okay, so what's going to happen is we'll go up like this and we'll come over here. So we want to calculate its velocity over here, right before it's the ground. Okay, so we have VF question mark. Now let's see what we know. Now look, this is our initial point, this is our final point. Remember, displacement is final minus initial. Okay, the y value of this minus the y value of this. So the displacement delta y is just this one. It has nothing to do with the distance. It has to do with these 2 points. It is y final minus y initial, okay, which is 0 minus 20. So it's going to be negative 20. It's downwards, so it's going to be negative. So the displacement is negative 20. This is distance, not displacement. displacement is this one. The line connecting the initial point and the final point is what we call displacement. All right, and it's downwards, so it's going to be negative. In other words, the final is 0, the initial is 20, 0 minus 20 is negative 20. So we know delta y equals negative 20, and of course we're told that the initial speed is 5 meters per second. Okay, and the question is to calculate the speed over here. All right, so we can use the following equation: vf squared equals bi squared plus 2g delta y. Okay, so we don't know the final velocity, but we know the initial velocity is 5. 2, acceleration is approximately negative 10, and delta y is also negative 10. Okay, it is no, I'm sorry, this is 10, this is 10 over here, so this is negative 10 meters. All right, so we have vf squared equals 25 plus 200. Right, so vf squared equals 225. So we have to take the square root, but you know the square root could be plus or minus. Okay, so it's plus or minus square root of 225, which is plus or minus 15 meters per second. So these are two possibles, but which sign do we pick, the plus or the minus? We already know just before it hits the ground, the ball is going downwards, right? Therefore we have to pick the negative sign. So the velocity is negative 15 meters per second. Okay, and now let's calculate the time taken. Okay, B, calculate the time taken. Calculate the time taken. Now you see we can use any equation that has time in it, so maybe this is the easiest equation to use, Bi plus GT. Okay, we just found out the final velocity is negative 15, the initial velocity is positive 5, and it's approximately negative 10 times t. Okay, so you've got negative 20 equals negative 10t. So it follows t equals 2 seconds.